Good morning, everyone. My name is Heather Ferguson, and I'm the Chief Staff Officer with BOMA, New Brunswick, and Prince Edward Island. And we want to say thank you for joining us today. I just want to go over a couple items we want to discuss before we get started. All attendee videos are off and mics remain muted. So if you have any questions, please use the Q&A button at the bottom of your screen. We will be monitoring the questions throughout the session today, and we will add the Q&A towards the end of the presentation. Today's presentation will be recorded and available afterwards by request. So I want to introducing our guest speaker today, we have Christy Cunningham. Christy is Executive Director with the Association of Consulting Engineering Companies for all Atlantic provinces. And over the past year, we've had the opportunity to work together on providing education sessions to our members. And we, again, appreciate the opportunity to host this session together again today. So Christy, over to you.
Thanks, Heather. And same from us. We really appreciate you partnering with us today. And it's great to see so many participants. So on behalf of BOMA TEI and ACCTEI, I'm pleased to introduce our speaker today, Steve Forrester. He is a code consultant at RJ Bartlett Engineering in Fredericton, New Brunswick. Steve is a licensed professional engineer in New Brunswick, and Steve acquired a degree in mechanical engineering technology from the Nova Scotia Community College in 2009, and then went on to graduate as a mechanical engineer in 2014 from the University of New Brunswick. Steve has 7 years of experience in the fire protection engineering consulting industry, with areas of practice including building and code and fire code consulting, performance-based alternative solutions and engineering judgment, fire and evacuation modeling, integrated systems testing, and fire safety planning. So with that, I will pass it over to Steve.
Thanks very much. My pleasure to be here. I'm excited to be speaking to this group. I think we maybe shared paths in the past. We grew up in PEI and went on to go to school in New Brunswick. So I think between those two experiences, I probably know maybe more than one of you attending this. So today we're here to talk about some changes in the 2015 building code. And I hope you find this information useful. On the agenda, we're going to get into some introductions, some mechanics of the building code, and a few of the particulars we're going to talk about. Then we'll get right into the meat of things when we get into the specific 2015 changes. And at the tail end, we're going to just touch upon some of the 2020, some of the new stuff that's coming in the 2020 version of the building code. And we're going to have a question period at the end, but as I was just chatting with Christy before the presentation, if there's questions that come up that fit where we are with the presentation and would promote some good discussion, feel free to send those on the comments, and we'll include them within. So the agenda will be some general evolution of the building code and the mechanics, how it works, how these proposed changes come to be. And then moving into the actual changes themselves, we're going to discuss the mid-rise combustible construction, which is a fairly hot topic. There's been some new kind of reconfiguring of foam plastics requirements, separating it from the combustible insulation sections. And then we get into the all popular smoke dampers, including some new air leakage conditions. There's a new section in the code that speaks to self-storage buildings, which will be interesting to talk about. Appendix D of the building code has some new testing information that we won't get too into, but we'd just like to identify that there's some new information there and some new tests that have been done to back that up. And then there's a few about X capacities and distance between exits, some clarifications on electromagnetic locking hardware, and then more or less just some harmonizing between the language in Part 9 and Part 3 regarding stairs, ramps, handrails, and guards. So RJ Bartlett is the company I work with, and we've been around since 1987. We operate out of Fredericton, Halifax, and we specialize in fire protection engineering, building, fire code consulting, fire safety planning, and we do some forensic investigations as well. This work we do all over the world, really, mainly in the Atlantic provinces, but a lot of Eastern Canada, Central Canada, some of the States, and even some of the Bermuda and Bahamas and things like that, which I've not had the pleasure of having a site visit down there yet, but hopefully in the future that'll be on the schedule. So we see Ben Coles is he's got a presenter's information in here. He's actually traveling today. He was intending to kind of tag team this presentation with me, but he's actually in the air, and the Wi-Fi service is not adequate enough to support even just an audio call. So, but Ben Coles has been with the company for 18 years. He's now actually the sitting president of the company, and he may end up joining in. And if so, that'd be great, because he'll help to provide some good color commentary. I myself am licensed in the province of New Brunswick, and I've been working in this fire protection engineering field, doing some building and fire code consulting for the last 7 years. And as Christy mentioned, I have a degree in mechanical engineering technology, as well as my Bachelor of Science in Mechanical Engineering from UNB. So we'll give some general background on the code now. The National Building Code is a model code. It's designed to be adopted by the provinces and territories. And as you see highlighted in yellow there, there's 6 provinces that have their own versions of the building code with modifications. Some even are considered to be more advanced than the National Building Code in some areas. And then just some regional modifications. And then we see the list of the remaining provinces and territories there, including New Brunswick and Prince Edward Island, who have just straight adopted the National Building Code of Canada. The code is written in English and French. It's adopted by the regulatory authorities. And it's amended, and as we kind of discussed, it's amended or supplemented to suit regional needs. This is the 14th edition of the NBC and the 10th of the National Fire Code. Typically, these come out in 5-year cycles as a rule. And the Canadian Commission of Building and Fire Codes is the commission that basically reviews and makes determinations as to whether these proposed changes or modifications to the code should be passed. Proposed changes to the code are also available for public reviews, and this typically happens in the fall of the rollout. The building code relies on and has a relationship with many standards, and they work together as well. And then we also have the Canadian Construction Materials Center that looks after new building products and new materials that are coming into the code and confirming their adequacy before entering the code. So the Canadian Commission on Building and Fire Codes is aided by these subcommittees or task groups in the identified areas. So these task groups may be recognized that there's shortfalls or need for adjustments in particular areas of the code, and they make suggestions and recommendations to the commission, which then make a say on adding it to the new versions of the code or subtracting it from. Each code provision is linked to objective and sub-objectives, functional statements, and intent statements. So the purpose of the building code is to detail minimal acceptable provisions. So they basically, you know, for example, yeah, the maximum travel distance can be 45 meters. Less than that is fine, but and they maintain building safety. The objective is to maintain safety, health, accessibility, fire, and structural protection. The 2015 MBC addresses design and construction of new buildings and substantial renovation of existing buildings. So if I have a building that was built in 95 and I want to update some cabinets and maybe change the color in a few walls, I won't be required to comply with the 2015 MBC. But if I was to say convert a classroom into an apartment, then I would have to revisit the contemporary requirements of the 15 code. The National Fire Code is a companion to the National Building Code. It also provides the minimal acceptable provisions, and its objective is to maintain the building safety in terms of safety, health, and fire structural protection. So the 2015 NFC provides minimum fire safety requirements for buildings, structures, and areas where hazardous materials are used, and addresses fire protection and fire prevention in the ongoing operation of buildings and facilities. So this is a retroactive code and applies to all buildings. So as mentioned there, the MBC applies to all new construction, constructions undergoing substantial renovation and reconstruction, buildings with occupancy changes, and if there's upgrading of fire protection. And then, as mentioned again, so the NFC is ongoing, so all new construction, all construction really, firefighting and prevention, fire safety planning, activities involving fire hazards, maintenance of fire safety components, limits on building contents, fire hazards outside of buildings, storage and handling of dangerous goods, storage and handling of flammable combustible liquids. And so here are some of the standards that work with the MBC and the ULC, CSA, NFPA, and ASTM. These standards, from my perspective, help kind of keep the building code from being even thicker than it is. For example, we have a standard for smoke alarms, and it's referenced in the building code that smoke alarms are to be installed per annual CS 531 rather than getting into the nitty-gritty details. Although there are some requirements noted in the building code, it leaves those kind of nitty-gritties for the standard. And then very much similar to NFPA 13, if a building needs to be sprinklered, it just needs to be sprinklered in accordance with NFPA 13. That's what you see in the building code. And then this NFPA 13 is a rather large standard in itself. So it contains all kinds of great information. When conflicts arise between standards and codes, the building code will take precedence. So some examples of this may be some specifics in NFPA 13. There may be some relaxations in there where the building code will identify particular areas that do require specific additional protection requirements. Okay, so that's the little bit about the mechanics of the code, and now we're going to get into the changes. So the National Model Construction Codes, now collectively called Codes Canada publications, contain almost 600 technical changes approved by the Canadian Commission on Building Codes, Building and Fire Codes. So these changes make the provisions in the 4 model codes clearer and easier to apply while introducing new concepts and expanding the codes to new areas. So the intent is that the code will improve as we as the passage of time. The intent of this presentation is to identify and summarize major changes and that significantly impact the application of Part 3 of the 2015 Building Code. So let's get into it. The first new requirement is the updates to the major occupancy and fire separation table. And they speak to adjoining Group A2 assembly and Group C, as well as Group A2 assembly and Group D office personal services, major occupancies. So this is as a result of allowances for these other occupants for assemblies within 6-story combustible construction buildings of Group C and Group D. And we're gonna just touch on kind of the major construction, or sorry, the major occupancy fire separation right now, but we'll get into some of the construction requirements a little bit later. So here we see a couple of superscripted notes in the drawing table, so 3 and 4. And then below we see the requirements specific to those. And those requirements basically indicate that the 1-hour major occupancy fire separation is to be increased to have a minimum 2-hour fire resistance rating, where a 6-story combustible Group C or Group D occupancy joins an A2. And this is a trend that we'll see throughout this presentation, where we have some enhanced requirements for these mid-rise construction buildings. This is the first of those. So 6-story, okay, so here we go. The 6-story residential, business, and personal services buildings are permitted to be constructed using traditional combustible construction materials. This is new. We got 2 more stories permitted for these combustible construction. The major construction requirements for these buildings is that the building height is to be not more than 18 meters when measured from the floor of the ground floor to the floor of the uppermost floor. These floor assemblies are to have floor assemblies throughout are to have the 1-hour fire resistance rating. Mezzanines are fire separations with a fire resistance rating. Mezzanines and roof assemblies are both required to have 1-hour fire resistance ratings. This roof assembly requirement is not typical for sprinkler buildings. So this is another enhanced measure that's required for these mid-rise construction, is to have their roof assemblies rated as well. And roof assemblies, if they have a height greater than 25 meters, they need to be of non-combustible construction or fire retardant treated wood. If the building has different layers, then these sections of the roof are permitted to be treated differently. And the ones that I've been working on, they have all been flat roof structures. And if that's the case, if we go back one slide here, we see that the buildings are not permitted to be more than 18 meters from the floor of their top floor. And if you have a flat roof, it's very unlikely your roof is going to reach the 25-meter range. So I'm not sure if that was one of the big reasons for them all being flat roof, but that's been the case from my experience. Load-bearing members are to have fire resistance rating not less than that required for floor assemblies being supported, which is typical to most of these major construction requirements. And then dwelling units that have more than 1 story within a building are required to have floor assemblies with a fire resistance rating not less than 1 hour. The gross building area, or the maximum footprint you can have, is progressively gets smaller as the building gets taller. The cumulative footprint does not exceed 9,000 square meters. So the gross area will never exceed 9,000 square meters. And here we see that buildings are not permitted to contain, so there's another enhanced kind of requirement for these buildings, but they're not permitted to contain Group A, Division 1 or 2, or sorry, 1 or 3 assembly occupancy types, care, treatment occupancies, or Group F major occupancies. So in any case, no F1s are permitted, but here we have F2s and F3s added to the list now. And a Group A, Division 2, or Group E major occupancy is permitted, but not above the 2nd story. And similarly, storage garage is permitted, but not above the 3rd story. So this is an interesting special case for these buildings. In order for these to apply, so Group A, Division 2, or Group E, major occupancy, to be located within these lower levels of the building, they are actually permitted to be of, those levels are permitted to be of combustible construction. This has not been the case in other buildings. For example, if I wanted to put a restaurant on the ground floor of a 4-story building that's constructed to that, I think it's 32251 maybe, but a 4-story combustible construction sprinklered, and I want to put a restaurant on the ground floor, I would have to view that ground floor if the assembly was major occupancy per the assembly's major construction requirements, which would then kick us into a non-combustible construction for that floor area. So this is a special provision for these mid-rise combustible construction buildings where they do permit A2s and Es within the building and of combustible construction. But as we previously talked about, the A2s are now required to be separated by 2-hour construction. And that was always the case for the Group E major occupancies. With respect to the storage garage, it says in the code that if the building is constructed wholly as a 32250 building, then storage garages are permitted up to the third story. But it also notes, it directs you towards part 4 of the code, which then says storage garages are to be constructed of non-combustible construction. So that particular imposed major occupancy construction allowance does not apply to storage garages. Here's just a little graphic that kind of identifies how it would look if you had A2s and Es on your first 2 stories. You would require that the floors be 2 hours, and then once you get above that 2-hour on the 3rd story, you can drop to a 1-hour floor assembly fire separation with 1-hour load bearing structure. And we noticed that the roof is 1-hour rated here in this case too. So a lot of this is repeated information for the 6-story combustible construction of the office and personal services buildings, but I will just identify some of the differences. So on this page, we have consistent building height, floor assemblies to be 1-hour, fire separations, and roof assemblies to be rated 1 hour along with mezzanines. This is consistent as well with respect to 25-meter high roofs to be of non-combustible or fire retardant treated wood, and load-bearing members to have fire resistance rating equal to the assembly that they're supporting. If you recall, we had a limitation of 9,000 square meters for the residential type mid-rise construction. Here we see that doubled as a result of the reduced risks associated with the occupancy type. Alert working daytime occupied spaces compared to overnight sleeping, the residential, which would have sleeping occupants, would be considered a higher risk for life safety. Here, the difference is, so similarly, we have a permission to have Group A and Division 2 and Group E occupancy types up to the 1st and 2nd story, but we see there's now an inclusion of Group F, Division 2, or Group 3, where we didn't have that with the residential mid-rise. The same applies. Combustible construction is permitted for these scenarios. And then similarly, the storage garage levels are permitted for the 1st, 2nd, and 3rd, but will need to be non-combustible. Here we have an interesting scenario where we have Group 3 is in the ground. The major construction, or sorry, major occupancy separation would just be the 1 hour between F3 and A2. And then we have a 2 hour separation required between the A2 and the Group D. Another enhanced design measure for these mid-rise combustible construction is that all of these buildings are required to have non-combustible cladding, or 90% of the exterior cladding is to be of non-combustible construction. Or they do give you this option that if you can satisfy this CAN ULCS 134 and the criteria noted there, then they will permit you to have combustible cladding. This was recently looked into by a colleague of mine in the office here, and an industry specialist confirmed for us because of the, we did some searching around and the listing guys, the UL product IQ and things like that. We looked, and there didn't appear to be any listed systems for this, and it's apparent that the criteria that's identified in this CAN ULCS 134 is actually very onerous and requires the combustible cladding to have been weathered. It's probably an expensive test, and those that appear to maybe meet the performance are just barely passing the performance criteria. So it's my understanding that there's no real listed systems right now that comply with this CAN ULCS 134. So what I'm seeing is a lot of non-combustible cladding being used on these buildings, and if they want the wood look, then there's products out there that are non-combustible but appear or give that kind of wood look. These buildings are also treated differently when it comes to how it's calculated to face a street. They're required to actually provide 25% of their building within, or an access route within 25% of their building, as opposed to other instances where if a fire department access route approaches and meets and gets within 15 meters from the building, that's enough to comply with facing a single street. But here they actually want 25% of the perimeter to be located within 15 meters of the street. Okay, so that's moving away from mid-rise construction. I guess I'll just prompt Christy. Has there been any questions on any of that I've covered?
No, I'm keeping an eye on it and I haven't seen any so far, unless anyone has any right now. I guess I would say no, Steve.
Oh, that's great. We can, maybe they can always bring them up at the end as well. Like, thanks. So some clarifications on foam plastics are now introduced to the 15 code. In both the buildings required or requirements regarding combustible and non-combustible construction. The big one is that combustible insulation is differentiated from foam plastic insulation material. In summary, the protection requirements are very similar. My understanding, one of the differences, or one of the reasons for this, is that foam plastic insulation, or foam plastics, can behave differently than other combustible insulation. They will melt and even drip and spread differently because of that material property. So that's I believe a driving force for this differentiation. So protection of foam plastic. Foam plastics forming part of a wall or ceiling assembly to be protected from adjacent spaces and going by these thermal membranes. So plastering, gypsum board finish, plywood finish, cardboard finish, quite a broad range of materials, not overly onerous. They are also permitted to be protected by sheet metal if it's not in a group A, B, or C occupancy type, or a thermal barrier described in sentence 315.15.2, which is the part of the code that deals with non-combustible construction and foam plastics. So an exception to combustible construction for methods we just looked at for separating is a walk-in cooler or freezer consisting of factory assembled wall, floor, ceiling panels containing foam plastics. These are permitted, provided protected on both sides by sheet metal, not less than 28 gauge thick metal with a melting point of not less than 650 degrees Celsius. No air spaces, so this they have to be sandwiched. The foam plastic has to be sandwiched completely, and have the flame spread rating not more than that the perimeter, more than that permitted for the space in which they are located. So non-combustible construction, foam plastic's a little bit more limited as to where you can use it and some of the thermal barrier requirements. So it's permitted to be installed in non-combustible buildings, above roof, decks, outside of foundation walls, and below ground level beneath concrete slabs on ground of the building. So that's basically permitted to be outside of the building envelope, as opposed to within the walls and interior walls. Foam plastic insulation. So any exposed surface, the flame spread rating not more than 500. Thermal barrier requirements are 1/2-inch gypsum board, lath and plaster, masonry, concrete, or Class B in the CAN-ULC S124 tested thermal barrier. So we see that that's a increase compared to what we saw previously for combustible construction. You know, gypsum board finish doesn't specify a thickness, plywood finish, hardboard, insulated fiberboard, and now we're getting into masonry, concrete, and minimum thickness of gypsum board. So exterior walls of non-combustible unsprinklered buildings, not more than 18 meters high, as long as the foam plastic has a flame spread rating between 25 and 500, these are the thermal barrier requirements that apply, similar to what we just saw, but now we have a little bit of an increase where we have a minimum thickness of the masonry or concrete specified. We have also some criteria from the CAN-ULC S101 thermal barrier where they limit the average temperature rise of that test on the unexposed sides of the thermal barrier to reach an average of 140 degrees Celsius or a maximum temperature rise of 180 degrees. And so if you do have it in your interior walls, within ceilings, within roof assemblies of non-combustible construction on sprinkler building, that is more than 18 meters high, you can see how, and we have a flame spread rating of between 25 and 500. We now get into a Type X 5/8 gypsum board thermal barrier, non-load bearing masonry or concrete, no less than 2 inches thick, load bearing masonry concrete, no less than 3 inches thick, and then some increases there in the CAN-ULC S101 test as well. Okay, so the next topic is smoke dampers. Smoke dampers have been introduced to the 2015 code to reduce the likelihood of smoke spreading into egress paths. Smoke dampers, or combination fire smoke dampers, are required in ducts and air transfer openings when, in specific locations, they penetrate assembly required to be a fire separation. Some of these specific areas are public corridors, assembly occupancies, care occupancies, group Bs, and residential occupancies. So these dampers are designed to close automatically in fire conditions to maintain the integrity of fire separation. a story that I heard, and one of the driving forces behind including these smoke dampers, combination of smoke dampers into the building code was there was an instance where there was a smoldering fire, I believe, in a nursing home in the garbage room. That smoldering fire did not get hot enough to activate the sprinkler protection and was able to allow smoke to migrate through the duct system and distribute it throughout the building, and resulted in some casualties because of that. So it's for those examples. It's to and the other factor is as many know, the leading cause of death in fires is not actually direct exposure to fire, but it's the inhalation of smoke. So the idea behind these smoke dampers is to really reduce the amount of smoke propagation through a building. There's so some new requirements with respect to just fire dampers of where these can be waived. So ducts are non-combustible with a melting point greater than 760 degrees Celsius. So this is just to clarify, specific to fire dampers. Ducts just charging 1.2 meters or lower from floor, having a cross-sectional area of 0.013 meters squared, or exhaust duct risers under negative pressure and rise at least 0.5 meters. Ducts through non-rated horizontal fire separation, or ducts connected to vertical service spaces directly to outside at the top of service space. Continuous ducts through vertical fire separations between suites, not applicable to residential care or detention. Ducts penetrating non-rated vertical fire separation, or a duct for commercial cooking, which would make sense. Those are hot gases being expelled through those commercial cooking ducts, so they could result in false triggers. Some examples of where smoke dampers are waived, so where they serve commercial cooking equipment, obviously smoky environments, which all inlet and outlet openings serve not more than one fire compartment. So if I had, an example of this would be if I had a rooftop air handling unit and it was ducted down through a building to, say, down through a couple of floors, and then only provided air or exhausted from that floor, and didn't have any other openings between the roof and that floor level, then we would not need smoke dampers in that ductwork as a penetrating fire separations. If we were to then, if that air handling unit was providing air to multiple floor assemblies, then each of those fire separation penetrations would then require smoke dampers. Another instance where they're waived is where they penetrate a vertical fire separation required for zoning for barrier-free path of travel. Provided a couple of conditions that the movement of air is continuous and the configuration of the air handling system prevents the recirculation of exhaust or return air. So the installation of smoke dampers, where smoke dampers are used as a closure in an air transfer opening, they are to be installed in the plane of the fire separation. In combination smoke fire dampers are used as a closure in a duct. They're permitted to be offset somewhat, but just to a maximum of 610 millimeters from the plane of the fire separation, provided there's no inlet or outlet opening between the fire separation and the damper. And each of these dampers are to be installed only in orientations that they've been tested in. So it's always good, specifically with dampers. I find it's manufacturers' guidelines are often something that poke their heads up in a day-to-day questions that we receive here at RJ Wireless. There's, can my fire stop around a fire damper can I put my fire damper in this type of construction, yada, yada. It's always good to just check the manufacturer's guidelines on these devices particularly. We now have some additional information on the leakage rate. This, I believe, was triggered with the inclusion of smoke dampers in the 2015 building code, but it's also carrying over to some requirements on door leakage in specific situations. But for smoke dampers, we have requirements for leakage and certain performance, and it's defined by this CAN ULC S1121 standard, leakage rated dampers for use in smoke control systems. In there, it says the leakage rating can be class 1, 2, or 3. A case study I can share with you is we had the question asked to us about a hospital in the Atlantic province. And they said, what kind of leakage rating class do I need to have for my smoke dampers, which are in a hospital? Can they just be whichever? What we found is it appears they can be just class 1, 2, or 3, but when doing some further investigating, the IBC, which is the International Building Code in the States, does actually specify that for health and care occupancies, they want you to have a minimum of class 2. So class 1 or 2 leakage rating to be used, or a smoke damper specified for that for their care type occupancies. But then another interesting component to that was that majority of these smoke dampers do perform. We haven't really seen, or I haven't come across a smoke damper that has a class 3. So I think achieving the class 1 or 2 is reasonably easy to achieve. So now we have some new requirements for leakage rate with respect to certain door assemblies. So installation of leakage rated door assembly is now required in fire separations in specific areas.
Hi, Steve.
Hi.
Mind if we go? I do have a question here about the fire dampers.
Okay. Great.
The question is, if fire dampers are waived for commercial kitchen exhaust, does that mean that when a commercial kitchen exhaust duct penetrates a required fire resistance rating, that no additional protection is required?
Yeah, that's a good question. So these the ductwork that's actually used for kitchen hoods is typically rated, but if I can, there may be an instance where the exhaust is maybe directed, goes directly to the exterior from within the kitchen. In that case, it's obviously not penetrating a fire separation, but if it does go up a floor assembly before it reaches the exterior of the building, that duct should be protected from the remainder of the building. So it's actually, like, whether it's a duct wrap or it's a duct type that's specific to kitchen equipment that has that higher performance for fire resistance rating, that will basically be a continuation of the kitchen compartment until it reaches its exhaust point. So that is how they go about doing that. They basically just rate the duct, or the duct is required to be rated from beyond that point of penetration through a separation.
Okay, and one other question not related to fire dampers.
Sure.
Are there any fire resistant coatings acceptable to protect foamed plastic in lieu of the barriers noted?
Coatings in the sense of intumescent products, I'm thinking like spray coatings and things. So with that, my understanding is that the ones that have been listed, from what I've seen, are all listed to rate non-combustible construction. So they can spray apply, and they do provide a fire resistance rating, but only to non-combustible surfaces. And the question was asked if this, some of these intumescent coatings could be applied to wood construction. And it was said that no, just from my research has shown that it's just been for non-combustible surfaces. And I would expect that that would be the case for foam plastic as well. And the issue is that I think the concern comes from the potential deterioration of a combustible surface. And if these coatings rely on its adhesiveness to the foam, then the heat that still dissipates through that intumescent coating would allow for the coatings, the protection to basically fall away. And so that's why we don't have listed systems using those products for thermal barriers. So not to my knowledge.
Okay, thanks. That's all the questions for now.
Okay, so there's a standard here that's referenced with respect to leakage rate. So air leakage tests of door assemblies and other opening protectives. The leakage rate applies to doors that are installed within fire separations in protected barrier-free floor areas, care treatment occupancies, public corridors, serving dwelling units in stories that are not sprinklered unless there's a second means of egress or a large open air balcony. So if in a smaller building, if occupants are able to find refuge on their balcony, then the door leakage rating is not required. And in buildings where we have horizontal exits through firewalls, those are also required to have this new leakage rating. Okay, so now we're finding ourselves in this new section of the code that deals with self-service storage buildings. For those of you who are not aware, this is largely based on a section of the Ontario Building Code, which has had this in there for some time now. And while they did adopt quite a few of the requirements that the OBC has laid out, they haven't quite adopted all of them, so they're just kind of dipping their toe in here. So in certain instances, we have still found ourselves looking to the OBC and presenting certain designs as alternative solutions to allow some specific features, and I'll get into that in the coming slides here. But these requirements are a new section and intended to kind of provide some specific requirements for these types of buildings. So here we have one of the conditions where we talk about like multi-story buildings and interior access implications, applications, will be considered in the future versions of the code. But for some reason, they didn't want to go all in for the 2015. So a self-service storage building, it's defined as a building that is open to the public for the sole purpose of providing individual self-service storage units, and they're classified as a Group F Division 2. For now, they're limited to a single story. No basement or mezzanines are permitted. Individual self-service storage units with external access only, which is not the case from the Ontario Building Code, but is for now in the NBC. Used for no other purpose than storage, with the exception that they do permit one dwelling unit, as long as that dwelling unit is separated for 2 hours. I believe it's intended that this dwelling unit would be a security dwelling unit or staff sometime. And adjacent offices to the dwelling unit are limited to 50 square meters, but are permitted to be considered part of the dwelling units. But no other major occupancies are permitted. One of the kind of special features of this section of the code is they allow you to group these buildings. So a group of self-service storage buildings are permitted to be treated as a single building for determining construction requirements and number of streets faced, things like that. And there's along with that, there's some spacing between these. So if you see on the slide there, like there's some minimum spacing between building 1s and 2 and 3 that allow for appropriate spatial separation, spread of fire, and fire department access as well. Here we're getting into another kind of hot topic that's been the result of quite a few growing pains for people in the industry. Integrated fire protection and life safety systems. So in the 2010 version of the code, they did have some requirements associated with this, and it read basically that the commissioning of integrated life safety and fire protection systems must be confirmed as a whole to ensure the proper operation of interrelationship between the systems. But now in the 2015, we have some additional guidance here, and it's more clearly laid out. So we actually have reference to a standard, and I'll just read it out here, where fire protection life safety systems and systems with fire protection and life safety functions are integrated with each other. Testing is to be done in accordance with CANDUL CS 1001, integrated systems testings of fire protection and life safety systems, to verify that they have been properly integrated. And then we have a list of examples on the bottom. So fire alarm, sprinkler, they're communicating back and forth all the time. In this instance, we also have verification processes that address a lot of the integrated communication between a fire alarm and sprinkler system, so that those happen aside from these CANDUL-C, there's not much work to be done in addition to these with respect to the integrated systems testing. But when we get into things like fire pumps, some emergency power, so how does your fire alarm behave after you've cut power to the building and it's running off emergency power by a generator or batteries? Smoke control systems are critical when it comes to integrated testing. We want to make sure that the sequence of operations happens appropriately. I can think of one example where if we had an interconnected floor space, an atrium, and we had smoke vent fans that were dependent on the main entrance of a building or the entrance of a building, doors automatically opening before the fans kicked on to ensure that we had our makeup air, that sequence would all need to be tested and confirmed to be working properly. So that's the intent behind these integrated systems testing. And some other examples, elevator recall, emergency lighting is coming on when appropriate, when required, and things like that. A couple of new things here with respect to distance between exits. So this particular requirement is new to the 15 code, and what it's doing is it's ensuring, or it's putting in this requirement to ensure that a fire on the exterior of the building will not obstruct multiple exits, the discharge of multiple exits. So they're requiring, if they're serving the same floor area, is to be not less than 9 meters or not less than 6 meters in a building that's sprinkled throughout, and where the 2 exterior discharges are located within 15 meters from a street. So just something to be aware of with respect to spacing of exterior exits, discharge of exit stairs. Here we have a new requirement to the 15 code. It's applicable to unsprinkled dance halls or licensed beverage establishments with an occupant load of more than 250 people. The requirement is that if the building is not sprinkled throughout the principal entrance, serving the dance hall or licensed beverage establishment where the occupant load exceeds 250 shall provide at least 1/2 of the required exit width. So this one is, my understanding, this one has come from largely from that Rhode Island fire, which was a major disaster. We had a nightclub. There's a few other factors at play with respect to flame spread rating of, that resulted in flame development and fire growth that was very high. But one of the main features of this was that we had an assembly occupancy of occupants that were all came in through the same main entrance, and that was their familiar exit to them. They weren't aware of exits that were located around back and through hallways and corridors and things like that. So there's a major pile up at the main entrance and actually ended up obstructing occupants from using that exit. So the idea behind this is that half of the occupant load half of the required exit capacity is at that main entrance. So we have some clarifications on mag locks here. That is group F1. So additional information was provided to address the use of electromagnetic locks in care and treatment occupancies where release of the locking device could endanger the well-being of a patient or residents. So we have instances where in these care occupancies where we have a lot of these mag locks being used to somewhat contain patients or elderly occupants to certain areas, and during testing or maybe false activation of fire alarm, and it resulting in a release of well, I guess mainly testing, but it resulting in a release of these mag locks, it could result in injury to these occupants that may find themselves in areas of the building that they shouldn't be. So just go through these. Electromagnetic locks are permitted if the locking device releases upon actuation of the fire alarm signal. The total time delay for electromagnetic locks in any path of egress to release is not more than 15 seconds. So this is also new. The previous version of the code limited the application of electromagnetic locks to just exit doors only. And here now we have a clarification that says you are permitted to have them within your egress routes as well. So you can have these delayed egress doors, but if you have more than one of these between a certain portion of your building to an exit, the cumulative delay of these doors cannot exceed 15 seconds. So you're only allowed to delay up to 15 seconds. Where a bypass switch is installed to allow testing of the fire alarm system, activation of the switch can prevent the release of the fire alarm system, as stated in clause B of the locking device during the test. This is that factor I was talking to you about with respect to just permitted to override the release of these devices during testing. But it has to cause an audible and visual signal to be indicated at the fire alarm annunciator panel required by Article 3249 and at the monitoring station specified. So this is new as well. So emergency lighting is to be provided at each door. This is a good thing to have, where a lot of the use of these, like a delayed egress door, is based on an occupant seeing the door and understanding how the door operates. And if you apply pressure, then it's going to release within 15 seconds. So I believe that's a big driving force behind making sure that it's a well-lit area under emergency conditions. And where they're installed on doors providing emergency crossover access to floor areas from exits in accordance with Article 34618. So if I find myself in a stair and I'm looking to an exit stair and I'm looking to get back into a floor area, but on that door, access back into the floor area, there is one of these devices with an electromagnetic lock. I'm required to be provided with a pull station and some signage on the door. So the locking device releases immediately upon the operation of that pull station. And it's got to be located on the exit stair side of the door, not more than 600 millimeters from the door. And the signage on the door is required to say re-entry door unlocked by fire alarm, with sizing requirements as well. Locks in care and treatment occupancies. The installation of electromagnetic locks in care and treatment occupancies requires special provisions to address the compromised condition of residents and the nature of daily operations, which we kind of already touched upon. One of the tools that can be used here to also limit and avoid these occupants, sensitive occupants, from overriding these electromagnetic locks and getting out is you can use these transparent boxes that set off an audible alarm when opened, and they can be used or installed to cover these manual stations that will release these electromagnetic locks. Also, one operational additional release device, so we can also have keypads and swipe cards to facilitate the free movement of staff and visitors in the building. This has been basically common practice for a long time, but I believe the 15 is just kind of spelling it out now a little differently in the new version of the code. So there's been quite a few updates to the requirements of stairs, ramps, landings, handrails, guards, etc. And some information to address design parameters. Yeah, so this is largely just harmonizing part 3 and part 9 of the code. So part 9 is actually had a lot of this information in there, and part 3 is more or less catching up to part 9. My understanding is that these are different committees, part 9 and part 3. So part 3 is basically just acquiring some useful information from part 9 in this section. This for one being, a diagram that's taken from the appendix that just identifies how to calculate the length of your landings within stairs and along ramps. If there's an angle at that landing. This wording is from part 9 as well. So one handrail is required to be on stairs that are less than 1,100 millimeters in width, and handrails required on each side, and stairs that are more than 1,100 millimeters wide, or curved flights of any width, and ramps. Intermediate handrails to ensure a handrail is reachable within 750 millimeters. At least one portion of the stair or I think that's supposed to say ramp and not tamp, between two handrails is the minimum width of stairwells stairways / ramps. All other portions of the stair or ramp between two handrails have a clear width of 510 millimeters or more. So a lot of this is just some additional clarification and even some relaxations brought into part 3. So if a stair / ramp is wider than required, handrails are to be located along the most direct path of travel. Handrails are to be free of any sharp or abrasive elements. Handrails, height of handrails, stairs, ramps, and on aisles with steps between 865 and 1,070 millimeters. And they're required to be continuously graspable throughout the length of the ramp and flights of stairs. Some of this information was already in part 3, obviously, as well. We also have instant here where exits that require a wall or well-secured guard on each side. If there's a difference in elevation of more than 600 millimeters between the walking surface and the adjacent surface, or if the adjacent surface within 1.2 meters of the walking surface has a slope of more than 1 and 2. The height of these guards is to be not less than 1,070 millimeters measured vertically to the top of the guard from the line drawn to the outside edge of the stair nosing or the surface of the ramp / landing. Here we have an allowance actually that's been brought into the 2015 version of the code, which actually says, I think before the wording was more like, as long as you can demonstrate that it doesn't prevent a hazard, you can have larger openings within your guards, but here the 15 comes right out and says that except where they serve storage garages, guards and industrial occupancies are permitted to consist of a top railing and one or more intermediate rails. So that's specific to industrial occupancies where we have trained personnel, but they're permitting up to 535 millimeter diameter openings there now, prescriptively. Otherwise, guards that protect a level located more than 1 story or 4.2 meters above the adjacent level are to be designed so that no member attachment or opening located between 140 millimeters and 900 millimeters above the level being protected by the guard facilitate climbing. And this is for mainly for children, so that they're not able to climb these quite easily, very easily. So ramp slope, relocation of ramp slope requirements for some occupancy types. Just letting you know that it's there, and it's a little different than the 2015 or the 2010, except for aisle requirements. It's the maximum slope of a ramp. 1 in 10 for any assembly, care, treatment, detention, or residential occupancies. 1 in 6 in industrial occupancy. 1 in 8 in all other occupancies, and 1 in 10 for an exterior ramp. So the NBC does no longer permit stairs to have open risers, with a few exceptions. Dwelling units, fire escape stairs, stairs that are principally used for maintenance and service, stairs that serve industrial occupancies and other than storage garages. So an example that I had seen was that there was an effort to close the riser portion, but it was using kind of a cage mesh. And we had some good discussions on that and the intent behind this new provision in the NBC. And so one intent behind this new requirement is that the toe can actually not penetrate or pass through underneath the run portion of the stairs. But the other factor is that if it's also to visually obstruct that opening, and to reduce an individual's kind of potential for getting that kind of like vertigo sensation, right? Like you don't want to. I myself, I picture some site visits where I found myself in some pretty high elevated instances, and I would be happy if I couldn't see down through. So I've experienced that myself. So not only do they need to be closed, not permitted to be open, it's also intended that those are visually obstructed as well. So we have some new requirements there for curved flights of stairs. Exit stair flights are to consist solely of straight flights or curved flights with a handrail on each side, a minimum run of 240 millimeters. And you know this is the critical feature. It's basically just limits the tightness of your radius here, but the run that conforms to the tread and riser requirements when measured at a point 300 millimeters from the center line of the handrails at the narrow end of the tread, and an inside radius that is not less than twice the stair width. The Part 3 is now permitting winders, right? These curved flights of steps in exits. So, and that would be true for egress stairs as well. So taper treads, consistent angles. So some requirements are that they need to be consistent angle and uniform rise and run. So if we see the three kind of winder stairs, they are to be consistent angle and uniform rise and run in those three steps. And their dimensions in accordance with construction tolerance for treads and risers when measured at 0.3 millimeter, 300 millimeters from the center line of the handrail at the narrow end of the tread. All tapered treads within a flight must turn in the same direction. Yeah, that makes sense. Here's a new requirement for some clarification on exterior doors. So the threshold when you open up a door cannot be more than half an inch higher than the surrounding finished floor surface, with the exception of, in our climate, we have where doorways are used to confine the spill of flammable liquids. But the other one is, places like New Brunswick and PEI where we might have some snow build up that would interfere with and block the door from being open. They are now allowing up to 6-inch high steps in the exterior portion of the door. This new requirement is to deal with doors that may open into parking lots where an exit door leading directly to the outside is subject to being obstructed by parked vehicles or stores. So the requirement is that a visible sign or physical barrier prohibiting such obstructions is to be installed on the exterior side of the door. And we have a little bit more on direction of door swing, where the code says every exit door is required to open in the direction of exit travel and swing on its vertical axis. But there's some exceptions. So doors serving single dwelling units, sliding doors, serving storage garages serving not more than one dwelling unit. Doors serving accessory buildings, serving not more than one dwelling unit. Doors opening directly to the outdoors at ground level that serve storage suites, not more than 28 meters squared on the first story of a warehouse building. And doors serving individual self-service storage units. So in a lot of those cases, you'll have like roll-up, overhead roll-up doors for those self-storage units. So this section is talking about some of the new tests and some of the new criteria that's presented in Appendix D of the NBC. And from our experience here, what we're finding is that Appendix D will always have its place, and it's good, useful information. But in reality, what we have now is some internet resources that I would say greatly supersede and make life a lot easier than trying to navigate your way through this Appendix D when you're looking for things like listed floor and ceiling assemblies and things like that. So one, for example, would be UL's product IQ, and you go into the wall or floor assembly selector and you punch in your criteria, and you're gonna, it's gonna spit out a list of available systems or systems that are available to you. And it seems to vastly outperform what kind of experience you're going to have for individuals looking to apply this Appendix D. There are instances where it is very useful, say for an existing building, if you're looking to maybe demonstrate that you have a rating on your ceiling assembly that you'd like to apply, and things like that, and your floor assembly doesn't appear to match easily with the systems that your internet searches are getting you, then yes, it's very appropriate and useful. But for the most part, we recommend just going and seeing what kind of ULC systems there are out there before spending too much time in Appendix D. And the reasons for the updates. So in large part, it's very consistent. They're not a whole lot of major changes to the 2010, but what they do have is they've updated some of the testing that they've done. So there's inclusion of a double half-inch Type X layer, now getting you up to 80 minutes, where that's new to the 15 code. Wasn't there before, but largely it's consistent with the 2010. So I'm just going to pass through that stuff there. And then that's going to bring us on to this sneak peek of some of the 2020 MBC requirements. The first one being the farm code, which hasn't been updated since, I believe, 1995. So they're going to come out with this new farm code, as well as they're going to introduce this new occupancy classification as a Group G agriculture. And this is intended to capture a variety of different agricultural types of facilities. One, relatively new type of building, but we see popping up all the time is some of these cannabis cultivation facilities, which have unique, hazards, and so that's the intent behind this new farm code, is to kind of catch up to some of these new types of agricultural type occupancies. Another big one is we can expect to see some encapsulated mass timber, which will mainly result in an allowance for high-rise wood construction. So this is some of these CLT type materials that are encapsulated with gypsum membrane and achieving fire performance that has these rainmakers comfortable with its performance, such that they're going to let up to 12 stories of residential Group C construction. As well as, it's my understanding, there's going to be some more relaxations or allowances with respect to occupancy types within, more provisions for these assemblies and mercantiles within these types of buildings. And then going back to the mid-rise, I believe there's even going to be some more advancements on those buildings as well. Some new requirements for visual signaling devices. They previously had these specific areas where they require visual signaling devices, but that's becoming less popular, as other jurisdictions have basically said it's better to just provide these, and not only where there may be hearing impairments and things like that, but it's a relatively inexpensive life safety device, and it's seen as a valuable one. So they're increasing the areas in which they're going to require visual signaling devices. The removal of wired glass is finally going to find its way out of the code. For those of you not aware, there's been some case studies where individuals have tried to break through this wired glass. And what happens is the glass may break, but the wires within result in injury from cutting, become quite sharp and ended up cutting individuals. Some circuit integrity requirements for conductors serving firefighter elevators are going to be in the 2020. This emergency lighting at magnetic locks, right now it's just noted in the section 34616 of the code. So where we went over and we identified that this emergency lighting is a good thing to have by these doors. It's now going to be actually in the emergency lighting section of the code as well. So that's a small minor change, but these types of improvements help us all navigate the code and not miss these sort of things. The height of the door release hardware is going to be reduced between 9 and 1,000 millimeters from the floor, versus what it was before, being less than 1,200. There's a guard exception, floor pits. some minimum dimensions regarding panic hardware, floor numbering within exit stairs, glazed area calculations in Part 9 houses, and interconnection of smoke alarms in Part 9 houses as well. And there's already been some of these requirements that have found themselves into the 2015 version, but it's I believe there's some new provisions coming regarding wireless type devices. So we've reached the end here, and gotta admit I'm a little dry, but I'm still happy to continue talking, and hopefully we get some good questions. I wonder if Christie's AirPods batteries have died.
Nope, I'm here. There are no typed questions at this point.
Okay.
I don't know if anyone wants to add any. If Heather, we want to change modes and allow people to ask questions verbally.
There's a few questions coming in, Christy, on the, go ahead on the
Okay.
chat there. Yeah.
Oh, perfect. Can a fire exit to outdoors also be used as a normal exit when there is not an emergency?
Yes. Yeah. The answer to that one, and I think that was a question that we maybe had just before coming into this, but that is correct. You can use an exit as a typical everyday come and go from a building. Yes.
Thanks for that. Anyone else? Here we go. You said that in BC overrides. What is the case in some municipal areas having stricter regulation?
So in the case, so I think I understand the question correctly. So if the building code requires a certain limitation, and then you have within your jurisdiction maybe some bulletins or some things like that that are in addition to the building code, then in those cases the additional requirements or the enhanced requirements are welcomed, right? Like that's what the authority is requesting or requiring. So those are applicable, and the authorities have the right and the ability to do that. Yeah. Is there a particular example? Is that kind of the thing? I'm thinking here in New Brunswick, we have there's a condition with respect to that I believe the fire marshal's office has put out with respect to spacing of dumpsters beside your building, right? And the spatial separation of those, where the building code doesn't necessarily address that. So in that case, we would apply the local rules for that.
Okay, here's okay. A couple more questions coming in here. So not relating to a 2015 code change, but wondering about venting an overhanging soffit within 1,200 millimeters of an unprotected opening. Are there options for using self-closing vents such as used in Western wildfire areas?
That's a good one. I'm not aware of any actually self-closing vents. So like kind of fire flaps, I'm thinking is what they're getting at. It would make sense, but I'm not familiar with that one in particular. Perhaps that individual maybe can follow up with me, and I can provide some maybe have a quick look and see if we can find an answer to that one. Yeah.
Okay, I can provide him with your email address, Steve.
That'd be great. Yeah.
Couple more. So you can't have more than one 15-second delay in an egress route, correct?
Yeah, that's right. Sorry, you can't have, you can have more than one delayed egress door or door hardware, but the cumulative time, so the time for each of those is, so for an example, if I had two of these doors between me and an exit, each of those could have, one could have 7.5 seconds and the other one could have 7.5 seconds of delay, but they wouldn't be able to be 10 or 15 and 15.
Okay, that was the follow-up question to that. Thanks.
Yep.
That is all I see for now. Anyone else? All right, Heather, I don't think there's any other questions.
Perfect. Actually, there's one in the chat there, Christy. I'm not sure if we already covered that one. I don't see it, but it
Yeah,
said you.
we did, yeah.
Okay, perfect. I just want to make sure you got that one.
Yeah.
No, I'll come back on. Thank you, Stephen, for taking the time to present to us today. And as well, thank you, Christy, for moderating this session. Lots of great questions coming through. So again, if you have any additional questions after the presentation, please feel free to reach out. We'll be sure to send any of your questions to Stephen and Ben as well to help answer any of those questions so we can get that to them. And as I mentioned earlier, the session today was recorded and will be available by request. So just feel free to reach out as well. So if there's no more questions, we won't keep you any longer. Again, thank you everyone for joining us. And I hope you all have a wonderful afternoon. Take care.
Thanks.
Thanks, Heather, and thanks, Steve.
Welcome.